All right, I think we can go ahead and get started.
Yeah.
If you are here for building for the future, DevSecOps in the era of AI, ML model development, you are in the right place. I'm Melissa McKay. I'm a developer advocate with JFrog. My background is primarily development. So I've been a software developer, software engineer for most of my career, a lot of Java server-side stuff, but I rarely meet a Java developer these days that aren't coding in something else as well. So I have a lot of experience in Python and Node and all of those other languages as well, and Go. But that's my primary background. That's where I speak from mostly, is from that developer experience. I will say AI and ML is new to me and pretty exciting. So I'm excited to share this webinar with Sunil. Sunil, would you like to introduce yourself?
Yeah, sure. Thank you, Melissa. So, hi, good morning, guys. Welcome to the webinar. My name is Sunil Bemarkar, and as I said, I'm based out of San Francisco. I work as a senior partner solutions architect here at AWS, and I have a pretty diverse experience in cloud computing and software architecture as well. And nowadays, my main focus is on DevOps and ML Ops in my current role. And I work with mostly the independent software vendors and JFrog, to provide them with strategic guidance, technical support, and insights in any of the solutions that we build. And the solution that is going to be presented by Melissa today in the webinar, which we are going to talk about, is one of the solutions I worked with JFrog on.
Awesome.
So that's fine. Yeah,
We have
take it
had the
over,
pleasure.
Melissa.
Thanks. We had the pleasure of working with Sunil on this. During this period of time, if you have any questions or anything that you want to ask us, there is the chat available. There's also the Q&A available. We may not be able to answer all of your questions during the live webinar. We will certainly try, but please post them anyway, because we will get back to you one way or another. All right, so something exciting for us at JFrog in this, field, we were able to make GA our release of ML model management. There's a lot involved here. We have some opinions on versioning, things like that. We would hope that it would improve processes around ML ops as well. And Sunil, I'm going to let you introduce the other integration.
Yeah, so we have Amazon SageMaker. And as you know, right, the machine learning is pretty complex and a hard process. And it's an iterative process. And there are a lot of different phases which you go through machine learning. And there are different tools for different phases and different personas who work on it. It's a little different than software engineering. And that's where Amazon came up with a managed service called Amazon SageMaker, which actually encompasses all those tools and processes where from a single pane of glass, you can do all of the ML integration or ML work from Amazon SageMaker.
Cool. So Sunil and I are going to give you a little bit of background. We'll talk about some things to consider when you're using both of these. If you aren't currently a JFrog customer and you just want to try things out for the ML model management, you can certainly go to jfrog.com and start up a new trial. It is currently available in all of our SaaS instances and self-hosted instances from version 7.77 on. And if you've got an Amazon account, certainly you can try SageMaker as well. All right, so first and foremost, this is something that's a topic that's near and dear to my heart. I do a lot of conference talks about supply chain security, things like that. My development background, I go back pretty far. So I was definitely around in the time when things were not as regulated per se. Maybe risks weren't as, they were always there, but maybe not as well noticed as they are today, as far as using insecure packages, things like that. But this term has come around today. It's used pretty frequently, software supply chain. What exactly is it? And I have a definition here. I've heard it used synonymously with like software pipelines or software continuous integration and continuous deployment. That is not really a good, they aren't synonymous. They mean different things. So when we're talking about the software, CI/CD, that kind of topics, we're talking about the process of going from development to production. The software supply chain is everything that we touch when we go through that process. So not only are we talking about the software that you use, so today we're going to be using Artifactory, we're going to be using SageMaker. We'll show you a demo of this later that I'm really excited to get to. But we're also touching artifacts out there. We're bringing in packages. We're bringing in models. We're using an infrastructure with Amazon. Our demo today is going to be about training, how to launch a training job in SageMaker. So just be aware of that, little difference when we talk about software supply chain, what we're actually referring to. Also, so here's the pipeline that I was talking about. This involves, just writing code at the beginning. I got really involved in a DevOps team later in my software development career. And I got a whole bunch of tools, new tools for me. I came from the era of sitting in a corner coding by myself, and then we, introduced Agile and we introduced extreme programming. So now I was coding with other people, but we were still throwing that software over the wall to an ops team who were involved in making sure that it got built and deployed successfully. So that's something that it came later in my career, being involved in a DevOps team. So now there's all this new tool set involved, including Artifactory, long history of using that particular tool. And then getting everything deployed into, some kind of infrastructure, whether it's in the cloud or whether it's, an on-prem installation or maybe an app that you're, getting delivered. But today we really need to be considered regardless of where our stuff goes or how we do our processes, whether we're using the whole DevOps idea or we're still in these silos, we still need to consider compliance and security. It is a pretty big deal to release software that might include a package that is not licensed appropriately for your use. This is a pretty big deal for companies who are paying more attention to that. It was so easy for me, I recall, as a developer starting out, to just bring whatever in. I like to tell the story of my daughter. She's a computer science student right now, and she got really excited about coding. And, I realized pretty quickly, when she comes home for a break, she's coding on my home network. So we had a good conversation about bringing in random Python packages, things like that to be concerned with and what you need to watch for and look out for. Developers love to create. We don't often have a criminal mindset. So sometimes we don't think about these things enough. All right, now let's talk about the other terms we might mention today. We're MLOps, similar to DevOps. MLOps obviously has the focus around machine language, and it also is a set of practices that help you with your ML workflows. We're hoping that what we introduced today, what we demo today, will help with a lot of those workflows and your current automation that you may have already in your organization. I said DevOps several times. We are now in the world of DevSecOps. DevOps originally came around because we wanted to eliminate that silo that I talked about. Developers not really understanding how things were deployed, not really communicating with operations, and this causing problems when you get to deployment and production. Well, DevSecOps is that same idea. Now we need to be communicating with our security teams, understanding what our risks are and understanding where we are in the process, what we can do within our role, of course, to help prevent catastrophes like a well-known CVE getting out there into your production, things like that. All right, I think we have enough definition there. Let's just take a quick look at the landscape. The AI ML marketplace has grown tremendously. Obviously, there's a lot of hype around it. A lot of new ideas are coming around, but AI is not new. It's been around a long time. It's been boiling for a long time. And it can certainly take a long time to develop useful models, train them appropriately. And really, it's about collecting all of the data that's needed in order to do this. This can take a very long time. A lot of effort has been put into it. We're now seeing today a lot of the results when we look at tools like ChatGPT, things like that. Now we have a lot more interest. A lot more developers are getting on board. I'm in the position of learning this, getting onboarded into these environments. And when I look at this slide, it was pretty overwhelming to me. All of the new tools that I had never touched, was never familiar with. There's one little square on here called continuous integration. That's the world where I lived and where I was most comfortable. The rest of it was new to me. So I'm excited about showing what we've come up with to help with some of this today. All right, Sunil, I have a question for you. What do you think is the biggest difference between software engineering and ML engineering?
So this slide is pretty good. I like it. It actually gives the overview and things about what AI ML market is. And there are probably more logos coming as we go forward with this thing, right? It's not going to be static as it is.
Guaranteed.
So to answer your question, the main difference between software engineering practice and ML engineering lies in the focus and processes. What I mean by focus is like software engineering, they focus mainly on development of applications, which with covering broad range of skills and processes, and then development from front end to back end development, database development, and infrastructure as well. On the other hand, ML engineering is a very iterative process, and the focus of it is on building and deploying machine learning models. And what they deal with is mainly the data. And that is like where you start with. Instead of starting with the code, you take the data and then you build the models and then code around it to make sure you get the results what you wanted. And then obviously there are like how you store the models and tracking the models that come into picture. So in a summary, right, if I would say software engineering is a broader domain covering application development, while ML engineering is more specialized, focusing on machine learning models for development and deployment.
Makes sense. Definitely makes sense. I think you described a lot of what I have on this slide. As far as developing applications, and you're right, exactly. The biggest difference, I guess, is the focus. Obviously, when you're developing ML, you've got to deal with a lot of data. So you have a whole nother role introduced that I am not used to working with, that I've had the pleasure to learn, is the data scientist in the very beginning, with collecting the data, augmenting the data, cleaning the data, getting it ready, in order to train and produce these models, and then analyzing those results. That part is interesting to me because some parts of it take a long time. These data sets can be huge, and the cycle that you go through is repeated over and over, as far as producing these models, training them again and again. You can't just let it sit. It can get stale. So you might be revisiting them frequently, or it could be years, but there is a difference there. One big difference to me personally is that I take comfort in being able to write some code and build it, and the result is always the same. But when you're talking about ML, it's different, right? You could have different results. We're dealing with something that isn't as black and white, especially when you start talking about inference, learning a lot of statistics, right? it's not as comfortable a domain for me, for sure. So there's a lot to be concerned here. Some similarities, let's talk about that. We still need to worry about security. There's still a lot of code involved. I've witnessed, a lot of Python involved in writing a lot of this stuff. That seems to be the background that a lot of these folks that are concerned with machine language have. So we see that used a lot. So we're still in this world of needing to deal with and recognize, vulnerabilities, mitigating problems in production when new malicious packages are found, preventing them from getting into our pipelines to begin with. We certainly don't want these things to get all the way to production and then be notified by our legal department that there's a problem. We have, our organization credibility to be concerned with, customer damages. I don't know about you, Sunil, but I've gotten multiple letters in the mail about my data being taken, in various ways. So all of these things, we need to be concerned with. And these are simple, clean diagrams that represent, the both types of pipelines in the ML pipeline. But there's still a lot that we need to consider here when we're working with models. And the challenge is that this particular focus is very much still like the Wild West. There's a lot of open questions, not really a standard full set of best practices. So we're still working on that. And we think that given that there is a lot of similarities between software pipelines and ML pipelines, it makes sense to bring those same processes to ML development as well. The same types of scanning, being concerned about licenses, being concerned about where our models are coming from. There's a lot of models available, through Hugging Face Hub, a lot of public available models. But then when we get into an organization where maybe you're using private customer data to build your models, you might need to be more concerned with keeping those somewhere within your organization that is safe and that is organized appropriately. So yeah, tracking their origin, making sure that where you store them, if you have a huge organization, you need to be concerned with people not mistakenly pulling the wrong artifact from the wrong place or the wrong set of data from the wrong place. You also need to be concerned with your security. You may not want particular teams to have access to particular areas of your lifecycle. There's all kinds of things that we need to be concerned with here. JFrog has an opinionated practice on versioning, which I will share with you later on. And I also have a link to a blog that talks about it more. I'll share with you at the end during the demo. But I find it really interesting because it's very similar to how Java artifacts are stored using that whole idea of a snapshot model. So that's particularly interesting to me. All right, I'm going to pass over to Sunil. He's going to give us a little more details about actual training, how that actually works, since that's what the focus of our demo will be on today.
Okay, so as Melissa said, right, machine learning process is pretty complex. It's not like a software development process, and it is an iterative process. So the main thing is you collect the data, first of all. And once you collect the data, it's not like you can just use it as it is. The major thing is you have to label the data, you have to curate the data, you have to make sense of the data. So that is where you kind of go through the process of preparing the data. Now, once you have prepared the data, the next step and that's where the iterative process starts. Kind of write code to build the model, what algorithm you are going to choose and what results you are expecting. Right? Once you build the model, then you train it with those hyperparameters, what you wanted to make sure you get the best results. And then you look at the results and evaluate the models. And once you look at the results, there is a concept called how much loss is generated and where does it fit. And nowadays there are tools which allows you to compare model performance for different types of models. So you probably would take your data set, run it with one model, and then look at the results if it matches what you are expecting. And then you might say, okay, it does 98% of the time, but let me see how the other model performs on the same data set. And then you take that data set, you run the same test, and then you can see. And based on the outputs and the statistics of the model performance, you can actually compare those two models. And while doing that, you can keep on iterating by either changing what parameters you are using when you are training the data, or based on if you want a different model, or maybe you're accentuating the data set in itself. You might be thinking that, okay, this is the data I had, but if I add some more attributes to the data, maybe that will help me, or the way I label it. So that is what the training is. And eventually, once you are ready with your model and you're trained and you think that now it is ready for me to take it to production, that's when you deploy the model. And deploying the model is, again, it's an expensive process. You deploy it, but then you start the inferencing on it. So you can use it to actually do what you want it to do, to query the model and get the results from it. So that's the process in a nutshell, which we are showing it here. But it's, as I said, the green box, when you say, it's like iterative process and you keep on training. And you cannot be comfortable once, even if you deploy the model to production, because you have to continuously monitor it. Because if you deploy the model to production, there would always be a chance that the data which you use to train the model, and it's probably got updated, or there is a new data set which is coming. So or the users of your inference, what you have provided, is probably asking for something more. So whenever you see those slippage or anything, you can add more data to it, or you can change the parameters, and then again start training the model before you go on to deploying the new versions of the model. Next one, Melissa. Okay, so this is where I wanted to talk about Amazon SageMaker. Actually, this webinar is about integration between how you can use ML, Amazon SageMaker, and Artifactory together to build and train the models, right? So as we know, and I think Melissa has mentioned in a couple of previous slides, it's a pretty complex process, the machine learning. And it's not just complex, it's expensive as well, right? And it's a process. So in each process, there are different tool sets which are needed for different phases of the ML journey. And if you're an organization, it becomes really difficult and hard to maintain those different tools, right? Because it comes from different vendors. And then you have different personas as well who are accessing those tools. You might have business analysts, you will have developers, you will have data scientists. So taking this into mind, AWS built Amazon SageMaker as a fully managed service that provides everything what different personas like developer, data scientist, and business analysts need, with the ability to build, train, and deploy the ML models quickly on AWS cloud. And what this does is it just removes that heavy lifting which was required in each step when I mentioned about this thing, right? So again, as I said in the previous slide, right, there are like different stages when you do the ML engineering. The first one is preparing the data sets, right? And SageMaker offers different types of tools for data collection, cleansing, and even pre-processing. So there are some of the services which you already know, like Amazon S3 is used for storage, but some of the new ones on the ML space is ground truth, as you can see, which helps you label some of your data sets, right? And then there is Data Wrangler to kind of visualize and transform your data. So this way, when you get all these tools in a single pane of glass, right, you don't have to go outside of that domain of SageMaker to go and see how you can do it or where you can do it, right? So that way, SageMaker enables seamless data labeling and preparation. The next phase is, once you have prepared the data, it's the build phase. And this is where developers and data scientists, right? And sometimes business analysts, but it's mainly developers and data scientists. They utilize SageMaker's Jupyter notebooks. And SageMaker provides built-in algorithms, right? And which allows them to start constructing the ML models. This stage is about experimenting. As I said, it's an iterative process, right? So it's about experimenting with not only different data sets, but with different algorithms and model structures to find what best fits the data and business problem, right? So here we have, means AWS has Studio notebooks, which are our Jupyter notebooks, which are fully managed. You can spin up and down these instances based on your need of GPU instances, like you can easily scale it up and scale it down. The next phase is training and tuning. Once you have built the model, then you go on automating the model training and tuning, right? So once you train it, in this phase, SageMaker handles large data sets and complex models as well. And it gives you an option to tune the hyperparameter and even optimize those to get the best performance out of this, right? So as you can see it here, right, from the slide, you can access experiments. You can even track and visualize your trials and experiments while you're doing this training and tuning. And last but not least is the deploy and manage phase. Once you are done training and tuning your model and you are ready to do it. So this is where you just, SageMaker allows you to deploy the model with just a few clicks, right? And it is into a managed scalable environment. And once you deploy the model, SageMaker also provides management tools for monitoring your model performance. As I said, right, once you deploy it, you have to keep on monitoring to make sure that it is giving the right results to your users and it is relevant, taking into time the process of doing it, right? And this monitor, it remains effective and secure over time also, because SageMaker provides that security. And there are a lot of different options on that front as well. From model monitoring, if you look, like some of the things which I could think of is avoiding model drift, right? That is kind of making sure it's accurate from that side. So that's kind of a SageMaker overview of a thing. So Melissa, can you go to next slide?
Yes.
Okay. So this is the ML stack which AWS provides, right? It's pretty comprehensive and it caters to all different level of expertise and various use cases, right? As can be seen, the stack is divided into 3 sections. The top layer is for application services. The middle layer is for ML services, and the bottom layer is for ML frameworks and infrastructure. So when we start on the top, the AWS provides application services like Amazon recognition. This is used for image and video analysis. Another one you can see is Amazon Poly for text-to-speech conversion. And then there is Amazon Lex for building conversational interfaces. Now these services, and there are others as well. I don't want to go through each one of them. But these services are designed for easy integration into your applications, requiring no ML experience, right? And so this is for something you want to integrate some of these AI services within your existing solutions that you don't need to. So if you want to do this, you don't need to be expertise in data science or be a data scientist or build the models in itself, because these are already built on models and pre-trained and ready to use services. So you can really take some of these AI services and link them directly into your current solutions based on API-driven process. Then comes the middle layer, and this is the layer where we are focusing on today in this webinar and what we have used to build the integration also. Now, this includes a fully, this layer simplifies the process of building, training, and deploying ML models. So SageMaker, which is, as I said, right, it's ideal for a developer, data scientist, and even for business analyst, right? Because of the tools and tool sets it provides for various of these workflows. So in this part, in the studio in itself, you can prepare data, you can build your models, you can train your models, as well as you can deploy your models into productions, all within this SageMaker studio in itself. Another thing is it also integrates with Canvas service, which is a no-code, low-code platform. And you can kind of move models over to the studio. So it's really a good fit if you have a need that potentially has some analyst, business analyst like that, right? Who maybe aren't as in the weeds in building models, but then kind of share some of the high-level models that come out of Canvas into the studio. So that way, then the data scientists on the team can interact with those models in the SageMaker studio. And then there is the bottom layer. Now, this is like AWS gives, what do you call, always works backward from the customer problems. And based on, we hear customers want easy to click, so there is a top layer. Then we want customers who want to do something on their own and have some control, so we have a middle layer. Then there are some customers who have expertise, engineering expertise to do everything on their own, right? So that's where that bottom layer provides the foundational frameworks and infrastructure for machine learning. Now, this bottom layer includes support, as you can see, for frameworks like TensorFlow and PyTorch, right? As well as you can see there are like powerful compute options on the hardware side, like EC2 instances, GPUs, and even in the generative AI space nowadays, AWS has their own chipsets, which is called Trainium for training ML models, and which is called, and then another one is Inferentia for high performance inferencing of machine learning models. So this is, as I said, right, really for customers that are very hands-on and can want to build their own machine learning stack just with their own kind of tooling. So, and then you can use a lot of these customization and optimization tooling for machine learning. So what I would say is, means in the machine learning journey, we have customers who would like to pick and choose what they want to use. So AWS, this platform doesn't force you to use everything what it provides. You can just use things for building the model, and you can use some other things, your own tooling for preparing the data. You can use or you can use everything from AWS. It's a one-stop shop. So that's what this ML stack brings into conclusion.
All right, so SageMaker already provides a ton of stuff for you. Where does Artifactory fit in? And like Sunil mentioned, the SageMaker whole framework, it doesn't really force you to use, it allows, I should say it this way, it allows you to use the tools that you already have set up in your organization. And as far as customers of JFrog, we've often had this question of, how can I utilize the SageMaker framework, but also utilize, what we already have in-house available for our engineers to use as far as managing our artifacts and managing our binaries. There are security scans in place. There may be curation in place to prevent things from coming in to the system that would harm the organization or the project that the engineers are working on. A lot of this it's a big investment for folks to make sure that the pieces and parts that they're using are safe. So in order to combine these two, let's just talk about where JFrog fits in this, in ML specifically. We introduced the ability to store ML models, Hugging Face ML models, within Artifactory now. So not only can you proxy models from public Hugging Face area, you can also store your own. So if you have proprietary models, you're using proprietary data, and you want to train and create your own models internally and store them internally, we also have a repository for that. the local Hugging Face repository. And I'll show you what these look like too when we get to the demo. As far as models go, I mean, we do have the scanning available to spot malicious models, any of the code that belongs there. This also helps to standardize the MLOps processes along with your other software processes. Everything is in one place. And again, we have some good ideas about versioning these things and tracking them. So these are the repositories. That's kind of what it looks like when you create these things within Artifactory. Obviously, you may already be using PI repos. We have the introduction of the Hugging Face repo. And then also Docker. Docker will come into play, especially using AWS's SageMaker interface for training and for inference. You'll need to be aware of how to use and utilize Docker images. So JFrog has a Docker registry as well. All right. So again, just to rehash, with MLOps, with JFrog, with the JFrog platform, you can get model hosting, versioning, caching from public repos and from Hugging Face repos as well. Vulnerability scanning, making sure that you have license scanning. That's one of the big ones here, paying attention to where everything is coming from and if you're even allowed to use it. Also, I just want to note the scanning it isn't just one and done. This is something that can be set up to constantly scan and update so that you are also notified of new vulnerabilities, new problems, new licensing problems that come in. All right, for use cases, why do we store everything in Artifactory? And then again, how do we even access these things within SageMaker? But the use cases here, the reason that this is important, I already mentioned proxying public models. You may be relying on these. Maybe the license is just fine. You need them. You've built a product around them. But what happens if the person originally maintaining this model decides they don't want to anymore? They're done. They're done with it. And they not only may not maintain it, but maybe they'll just flat out remove it. This is a problem if you've built around it. So always make sure that everything that you use is cached internally, stored internally so that you don't run into those issues. Again, we spoke already about storing and managing proprietary models. Your data can be proprietary. Maybe you're using internal customer finance data to create some type of functionality that you share with your customers. Obviously, this isn't something that you would want to just throw out on Hugging Face in a public venue. And then standardizing the MLOps processes across various teams. This makes it easy to go, to move between teams. Always, this comes up with several opinions. Everyone's going to want to do their own thing if you just let it go. So the best way to get agreement, make sure that everyone is compliant, is to put in this automation, which enforces agreed upon policies. We talked about licensing. Also ensuring security. So if you're using public models, you're using third-party models, you want to make sure that the origins of those models, the components that were used to build them, are also safe for you to use. And then visibility into your ML development. This is important. You really do, just with any software in your organization that you produce, you need to know what was produced. You need to know when. You need to know who was involved, who accessed it, who touched it. There may be different access permissions required for different teams or different areas of the system. And then who, basically just full visibility on who did what. This can be involved also in regulatory compliance. There may be some requirements there that your organization needs to meet, and these things are important.
Yeah, so far, whatever I have talked, right, and what Melissa has said, so these, I think this probably explains it itself. But at the top, what democratize ML innovation means is because it is now accessible to all the roles, developers, data scientists, business analysts, and for all skill levels. So what this does is it lowers the barrier to entry for people to go and build the ML solutions and access it. Another significant thing is it accelerates the ML lifecycle from data pre-processing, model building to training and deployment, because you have everything in a one-stop shop from Amazon SageMaker. It also, another benefit is there are tools which allows you to deal with large data set, which is a common challenge in ML. And it helps you with tools like Data Wrangler, which allows you for easy data preparation, cleansing, and feature engineering as well. So that allows you to prepare data at scale. And then ML ops is a big process. We have been through DevOps, now it's ML ops, and that's where JFrog shines. And they try to make sure that whatever the things is flowing through that ML ops process, from preparing the data, building the model, training, right? It should be a streamlined process. So SageMaker helps in streamlining that ML process. And finally, the improving the ML governance, right? It offers features like model monitoring, audit trails, and version control, which are crucial for maintaining quality and integration of ML models. So along with JFrog's pipeline, right, where they take care of who built what, when it is built. So this is where it fits in, and it provides ML governance. So these are the benefits. So Melissa, if you could go to the next slide. Yeah. So as you know, right, SageMaker, for people who are using, right, it reduces the time and cost to train and tune the ML models, right? And without need to manage your own infrastructure or any of those things. In addition to this, we have built-in libraries and tools. Like SageMaker works with popular open source foundational models such as GPT, BERT, and DALI, and even ML frameworks such as PyTorch and TensorFlow. So what we did is, now, in addition to this, SageMaker training now supports using container images with pre-installed frameworks or algorithms stored in your own private Docker registry to build the ML models. And that's where the JFrog Artifactory comes into picture, right? And as you can see from this use case, right, typically in the SageMaker, so far it was SageMaker was using ECR as the de facto registry for pulling the container images. And there were like, as this customer has noted, that when they were trying to do that, their security team actually did a review and said that it would be beneficial if you used JFrog Artifactory, because they do use JFrog Artifactory for everything. So why not use that? And it has a feature where they can know who used, who accessed, and who built it, right? So that solves a number of, what do you call it? Number of software supply chain concerns which the organization had. And this is what we are seeing. Means obviously there was a roundabout solution where you could actually proxy the Artifactory into ECR and then use it. But with this innovation now, with this feature set, this is what the webinar is about. We were able to build this solution, and JFrog has taken it to the next level. Next one. So this is the architecture diagram that represents the SageMaker environment using private Docker registry, a JFrog Artifactory in itself, right, to build ML models. And following this slide, I think Melissa will go through the demo. But what it shows is, if you want to do this setup, you have to create a VPC with private subnet, security group, and VPC endpoints to access S3 and other services, right? This is a requirement to restrict internet access to make it more secure, and monitor and inspect traffic, and also to control data flow from SageMaker resources. Then we have S3 bucket, which has the training data, and it is used to store that data that will be accessed for ML model training from the scripts. Then, as you can see on the left-hand top side, there is AWS secret. This is the place where we centralize and store all the sensitive data needed for authorization and access to Artifactory and necessary repository. So when you are building this integration, this is where you will store your Artifactory credentials, which then would be accessed by AWS Lambda, which is another resource which you have to spin up, because that is the one which provide access credentials, which pulls the access credentials and provides access credential to SageMaker to authenticate the private Docker registry in Artifactory. Right? And then you will have the training script, which will be responsible for parsing the job input arguments, loading the training data, configuring and training the models, retrieving necessary credentials, and then saving the model and related artifacts to Artifactory. And there is a blog as well, which we will share at the end of this thing, which actually helps you go through step-by-step process of how to set this up. Okay.
Excellent. Thank you, Sunil. Lots of information. This is pretty exciting for us because I think it's just a full-blown solution end-to-end for this process. I'm going to show a demo. I'm going to go through it pretty quick, but I'm also going to supply you with the resources that you need if you want to try this on your own. First and foremost, I'm going to go ahead and give you the link to the blog that Sunil mentioned. It has some more information in it. I'm just going to type it in the chat here. It's also on one of the slides at the end. I just don't want you to miss it. Okay, first and foremost that I want to share is I just want to give you an idea of what this looks like. So I'm going to share my Amazon account with you. And basically, I'm going to be careful here. I'm a guest in this environment, so I'm not going to show you a lot of stuff in here, but I just want to show you when you're in SageMaker, what we are going to be showing today is just how to launch a training job. And along the side here is where the training jobs are listed. You'll be able to see that I've run several. Lets me know how long they've run. If I were to drill down into these jobs, it gives me a lot more information on when it was launched, what artifacts were used to launch it, etc. So during this demo, I'll start up a job. I'll show you that it is started. But first, let me go to Artifactory. This is another environment I'm a guest in, so I want to be respectful here as well. But I want to show you what's required as far as the repositories that need to be created, what we're looking for at the end of our demo here. So this is just a list of all the typical artifact page. If you've dealt with Artifactory, this is probably the default view that you see. The ones that we care about the SageMaker Docker Virtual. This is a Docker registry that handles the TensorFlow image that we're going to be pulling from Docker Hub, as well as the custom image that we'll be using. Today, we're going to be using this image right here, a test image. I just labeled it 0.2 for reference. So remember that. The next thing that we care about is our Hugging Face local repository. This is what we've set up to store our models. I have a place in here that I've been working in, that I've been storing models that I've been training using the SageMaker training jobs. And you can see I have various versions here. Each one of these folders I have named specifically V1, V2. This is my part in the process, is naming these. And then you get a timestamped version of the model. Now, like I said before, this is kind of an opinionated versioning scheme, very similar to snapshots. So if you choose not to name your model, you, of course, still choose the repository it goes in, but it goes in the main directory here. And again, a timestamp version. These might be just intermediate results that maybe you don't want to keep. They're not ready for release. So it's just a way of organizing your versioning here. What I'm going to create today is version 3, and we'll see that happen. I'm going to post a blog on the versioning Let me find it here. All right, that'll give you some information on this versioning scheme that I talked about, as well as someone had asked what versions of Artifactory this applies to. So there's some information in there that is applicable. Okay, so another resource I want to share with you is a GitHub repo. This is public, available to you. I'm going to go ahead and share the link to it in the chat as well. This is set up for you to pull, you can use. There's a lot of variables that you need to set. We'll walk through that in a bit here. I'm going to go into this train directory. We do have some other things you can do, but we're going to focus on the training job today. And I like going from outside in. So we talked about what we're going to need. We need the Docker images. We need the scripts. This is a training script that actually launches the job in SageMaker. So there's a lot of stuff in here. I'm going to go ahead and run this script locally on my machine just to get it started. And then I'm going to walk through the script and give you some more information on how it works. All right, I just want to make sure that that training job has started. We should be able to see some activity here in a moment. And here we go. We have a training job in progress. So let's walk through quickly what this script does. Okay, so first of all, the image URI. This is the super important bit. This is our custom image. We're using a image that has a base of a it's the latest GPU Jupyter TensorFlow image is what we're using. And then we have added to that image some customizations of our own training script. So this is the image that the training job in SageMaker is going to pull from Artifactory. There's some setup here that we need to specify that have to do with the VPC. Yes.
Yeah,
yes.
can I? So this is the setup which I was talking about when I was talking on that architecture screen, which we saw in the previous slide. So once you set up that architecture, right, and this is where you specify the security groups, you specify the subnets, right, and the training credential providers, like that Lambda ARN. So, and then you have to mention the VPC. So these are the steps you have to mention in the script to kickstart the training job to make it work. Please go ahead, Melissa.
Thank you, Sunil. Some other items that you can adjust as needed. We have an instance count of 1. Obviously, this is a demo. We're only going to go through 1 iteration. We definitely minimize how much money we're going to spend doing it. The role here is the execution role that is related to your SageMaker domain. The data set is the MNIST data set. Yeah, that's a TensorFlow data set. It's basically a collection of handwritten images. I've posted a link in the chat if you're curious about that. Basically, it's just this idea of being able to take an image and detect what digit is actually it's representing. We've put this data set in an S3 bucket, and that's where we're going to pull it from during the training. The repo ID, this is the repo that I showed you earlier, the one that's named Melissa M. This is the part that you get to decide here where you want to store it in Artifactory. And then, of course, the secret with all of the critical information that you need, the sensitive information that you need. And then the hyperparameters, making sure that that image URI, that's the key of using your own image here. All right, we needed to put the train script. I'll show that to you very quickly. Not a whole lot of information here. Just so you know, I'll put a link to this as well. We are heavily using the SageMaker Python SDK. I'll put a link to some documentation there. And that's what we're doing. We're basically, during the training, we're getting the secret. We're making sure to, get the information that we need. And we're also uploading a model. Another thing we're doing is we're generating a README, which will give us some good metadata that we can go look at. All right. Lastly, I just want to show you quickly the Docker file. The Docker file here is something that actually contains the transcript. So you can see where you can, when you're building the Docker file, you can see that we're using this base image here. It is cached in Artifactory because we're proxying that request to Docker Hub through Artifactory. And that's basically all we need. Oh, another thing to consider, we are using a build secret, a Docker build secret, in order to provide the credentials you need for pip. So for your PyPI repository in Artifactory, you're going to need to set this up. And there's some instructions in the pip conf file to do that. It basically just creates this file within the Docker build so that when you are building the script, it knows where to get your Python packages from. All right, so the training job should take about 5 minutes. Let's just go see if it's done. It looks like it's still in progress here. In the meantime, what we will see is a version similar to this. It will pop up here once the model has been stored, and you're going to get a lot of information here. This is the README that we walked through. It can contain whatever you like. In our system, we have it track the date, we track the data set, we track who ran the job, what the job name was, anything that you want in there. All of that's available in the GitHub repo. Okay, I'm going to quit here because we have 2 minutes before our webinar ends. So just lastly, reach out to us if you have any questions. There's the blog here. I posted both of these blogs already, but you can learn more about how to do it and get some step-by-step instructions as well. There's the AWS Marketplace, and I have some contact information for both Sunil and I. Sunil, did you want to say anything?
No, thank you. Thank you for joining. I think this is pretty exciting. It was asked from a lot of customers. That's why we built this, right?
Yeah.
Now that ask is fulfilled. So we
Yeah.
should see. And if you are using it and you are in the process of ML journey, if you're already there, you can switch to using JFrog Artifactories. Or if you're not, then at least consider using JFrog Artifactories as part of SageMaker. And as Melissa said, this integration is already available in all the SaaS versions, or at least the current SaaS version, I believe.
Excellent. Success. This is a success story of working together and getting something up and running that will hopefully make all of your lives easier.
Yeah.
Right. Reach out. Again, if you have any questions, I put my LinkedIn in here. Please, if you try to connect with me or follow me, give me a note. Tell me where you're from, where you came from, so that we can chat. All right.
Right.
That's all.
You.
Thank you.